talking about here in this video is going to be the OhioView Presents Geospatial Applications Workshop. And this was one of OhioView's high impact activities that we held in 2020. I'm Brad Shelito. I'm the professor at Youngstown State University. I am one of several PIs for OhioView. I serve as the chair of the board of directors of OhioView. I've also been extensively working with AmericaView in this capacity. But what I want to talk about is our OhioView Presents workshop. This was a geospatial applications workshop that was held on February 7th of 2020. And it was a free workshop. The funding from OhioView went in order to pay for participants to have lunch and snacks, coffee. It went toward any printing costs. It went toward any parking fees for people had to come to campus to park. And this was held by 5 different PIs here within OhioView, coming from the PIs that are listed there on the screen, from places like Bowling Green University, Youngstown State, Ohio University, the University of Toledo, and the University of Dayton. And all of these are very geographically dispersed places across Ohio. But this is one of the benefits here with having multiple different locations within OhioView, is that we have all of these various professors that we can bring together. Even though we're going to be geographically distant, everybody was able to go contribute in toward working here inside of this OhioView Presents workshop. Now, the way the workshop was going to be set up was because everybody was going to be dispersed around Ohio, was that each one of the locations was going to have people there on site. So for instance, at Youngstown State, we were gathering people from the nearby region of Youngstown, Kent, Cleveland, Akron, all of the points within that region. And then Bowling Green, Toledo, all of the other locations were all responsible for doing the same. So each of the locations had people there from their respective regions. Then what we were going to be able to do was then each one of the professors at those locations would be lecturing on a particular subject to the people there at their location, and then also broadcasting that information out using Zoom to the other locations at the same time. So with this thing of using Zoom, we were able to have presenters talking to their people on site while at the same time talking to people at the other locations. That way, when people were going to be working on things, they would be able to have questions from any of the locations. The lead of that particular session would be able to step in and answer questions for it. So with this idea in mind, we had people on site and also to be able to be broadcast out. And also, this simply wasn't a lecture or a webinar series, but each one of the participants at each of the different areas was then going to be working hands-on. It was going to be the function of each of the PIs to go present their topic, and then also present things that the participants would be working on hands-on. A manual was created. It was given out to each one of the locations, and then everybody would be working hands-on on that particular assignment. So it was a mixture of the theory and background, but mostly getting people getting their hands dirty, working with geospatial technologies and remote sensing. The session that we had here for our activities shows that this was a full day workshop. We have started promptly at 9 a.m. and we finished at 4 p.m. And we had 5 different sessions with breaks in between and a lunch break for the participants. And again, each one of the sessions was being led by a professor at a different university, and then also having people working hands-on with that particular topic. So what our sessions were, our first one was focusing on creating dashboards within ArcGIS Online. A dashboard is going to be taking data off of a web map, and instead of simply showing locations of different structures within a county, it's a way of creating a standalone web app that allows you to see at a glance the names of the structures, a count of the structures, the distribution of those structures in an interactive published web map. And in this case, we are looking at focused on building one of these dashboards and publishing it within that amount of time. Our second presentation dealt with LiDAR applications. With LiDAR, we were going to be looking at downloading LiDAR point cloud data sets, bringing them into this free open source tool called the Fugro viewer, and then having the participants go and work with different kinds of LiDAR applications of the data. Our third one of our applications here is going to be using the Globe Observer app. Globe Observer is going to be a free app that can be downloaded onto a smartphone, and then there are multiple different types of applications that are working with it. In this case, participants are going to be outside using the Globe Observer app for measuring tree heights, and then bringing that information uploaded through the Globe Observer app back to NASA, and then examining what the results were. Also, as part of this session, we had two guest speakers to come in, Peter Nelson from Oregon State University and Brian Campbell from NASA Goddard Space Flight Center, who are both working with the NASA Earth Science Education Collaborative to talk about applications of the Globe Observer app and how we're utilizing these types of tree height measurements. Our fourth session was looking at utilizing Landsat 8 imagery, and then how land surface temperature was going to be able to be calculated from the thermal bands on Landsat 8. Bring that information into GIS, and then going through having participants walk through the various different calculations to turn thermal band measurements into land surface temperatures in Celsius degrees. And our fifth session was going to be about looking at image classification using the region of interest tool within ENVI, where participants began with an initial remotely sensed image and a set of classification areas. They were able to delineate out those locations using the ROI tool and then perform image classification. So in the end, we had a very successful high impact activity. This was a full day for the participants. But again, this was a free workshop for the participants. We had over 65 people attend. We had more than that sign up. February weather, what can you do sometime? But it was extremely successful to bring together all of these people from all of these different locations together and be able to present all of these various geospatial and remotely sensed applications for our high impact activity.
In this video, OhioView presents the Split Remote Sensing Integrated Research Educational Cascade Model. This was another high-impact OhioView activity in the period between 2017 and 2020. I'm Anita Simic-Milas, and I'm Associate Professor at Bowling Green State University, Ohio. I'm also one of PIs for OhioView, and I'm actively involved with AmericaView. The Split Remote Sensing Integrated Research Educational approach offers high school and university level students the opportunity to gain hands-on remote sensing learning and research knowledge in an actual research setup. This program has also been designed to help educate K-12 teachers who could then contribute to creating a diverse and highly skilled future workforce. The main components of this program are split through art exhibitions, split remote sensing workshops, field campaigns and hands-on activities for high school and university students, and educational YouTube videos and webinars. I will describe each of these on the following slides. The project started with an exhibition called Split Through Art, where students displayed the visually appealing remote sensing images retrieved from NASA and ESA Earth as Art websites. The exhibitions were organized annually at BGSU, and they were open to public. The goal was to spark the interest of students across different disciplines in remote sensing through art. The events were advertised through various websites and local newspapers. Students were encouraged to select images that they found visually attractive. Each student presented a selected image and collected information about the image. Students also organized the exhibitions, so they did everything from selecting images to displaying them and hosting the events. Each year, new students would add 15 to 20 new images approximately, making the image collection larger each year. Each image was accompanied by its own story, including information about remote sensing data and sensors, geological and historical information, and environmental issues related to the image. This way, students learn about different sensors' capabilities and specifications, and also about remote sensing applications and possible projects at the same time. Split remote sensing workshop events consisted of multiple lectures by professionals from NASA, NOAA, and BGSU, hands-on experiences with the remote sensing software, and panel discussions on remote sensing education. High school students and their teachers also attended the workshops. The topics were mostly related to the use of remote sensing and the drone technology in particular for water quality. During the hands-on session, high school students and teachers had the chance to learn the basics of image manipulation and visualization. During this one-day workshop organized at the BGSU in 2017, NOAA and NASA researchers shared their knowledge about monitoring harmful algal bloom in Lake Erie. Other lecturers presented their perspective on remote sensing research from their experiences while working in academia and industry. Interactions between students and government experts, such as those from NASA, USGS, and NOAA, inspired students' interest and involvement in Earth and space sciences. The interactions between students and the NASA experts, for instance, also motivated the students to participate in the panel discussion. Experts on the panel discussions focused on how to attract students to the field of remote sensing and how to keep them interested throughout high school and university. The panel comprised of an associate professor of education, 2 experts in the remote sensing field from NASA and BGSU, a high school science teacher with 2 of his students, and the undergraduate and graduate students. The discussion underscored the importance of several factors for learning success. Drone-related technology is advancing, and the modern world of precision agriculture is moving ahead with the times, bringing up complex issues such as water and soil quality. These issues were addressed in the workshop held at BGSU titled Drones in Agriculture, What We Need to Know. Representatives from USGS and FAA, together with farmers, presented some of their findings and exchanged various ideas related to the use of drones in agriculture. In addition to in-class lectures, fieldwork and hands-on activities also involved high school students and teachers as well as university students. These activities help them to understand remote sensing basic concepts, and active learning and team building atmosphere were a driving force behind the peer learning between the students. Huron High School and Bowling Green State University students learned how to fly a drone and how to use a spectroradiometer. Then collected data were displayed and analyzed using open source software available to all. Collaboration was also established with the St. Ursula Academy High School, where students learned how to use the spectroradiometer and collect measurements from soil and crops, and how to derive vegetation indices. We met several times and worked together on their project. One of their projects was related to the impact of different types of soil on crops. The goal was to help understand Lake Erie watershed problems. The girls won the Lexus Eco Challenge Award in November 2019. The last component of the model YouTube videos and webinars, Split Remote Sensing, have secured the ongoing engagement of teachers and students in the field of remote sensing. There are already several educational videos, and they are all recorded by students. They include various topics such as how to download and pre-process data, how to use statistics and create a source code for some basic calculations, etc. For instance, one of the YouTube videos shows how to set up and fly a drone along the Lake Erie shoreline, where drone landing could be incredibly challenging. In addition to the mentioned Cascade research educational program, Split Remote Sensing also organizes more advanced international summer schools for young professionals. These annual schools are organized in different countries, and they present best insights into most recent techniques learned from top international professors and researchers through hands-on sessions and lectures.